with our graphs of logarithmic functions in lesson, what lesson is this again? 3.3. Sorry, I just don't know my lesson number. When we graph log functions, okay, you'll notice here, this says when we graph log functions, we're only going to use y equals log of x and y equals natural log of x. So we're only going to use our two basic logs, which is the log base 10, and remember natural log is log base e. Okay? We graphed these functions in chapter 1 when we learned the 12 basic functions, what we were just talking about. And what I will reference is that whether it is base 10, base e, base 2, base 20, all these graphs are going to be this basic form right here. Okay? Where the basic graph crosses through the point 1, 0. It runs along the y-axis as an asymptote, so it never crosses across the y-axis. Okay, that's your basic graph. That was back in lesson 1.3. In 1.3, I think the equation we referred to is natural log of x at the time, but it's the same thing as log base 10 of x. And in fact, if you graph them on the calculator, you're going to see that they are very similar. And in fact, let me put these up here real quick. Okay, so you'll notice I have my blue y1 as log x and my red y2 as natural log of x.
That is not the same thing.
It's the same graph with it's like essentially it's a different vertical stretch. Okay? It's essentially the same vertical stretch. Now, do remember the calculator has a little bit of graphing failure here in that the graph doesn't actually end right here. It looks like the graph ends right there, and it doesn't. It goes down along the y-axis as an asymptote. Okay? But the difference in the red and blue, they're the same shape graph. It's a difference in vertical stretch, vertical shrink. Okay? Kind of like how you have parabolas. They're the same basic shape, different widths. Okay? Now, as we look at example 8, we're going to do a couple of things. We're going to describe, so we're going to use our words. And we're going to describe using our transformations, how to transform the graph. And we're going to use, as we talked earlier, the basic graph of either natural log of x or log base 10 of x into the graph of the given function. And notice it says sketch the graph using your calculator, labeling the asymptote and x or y intercept. So we're going to kind of try and talk about on our own some, and then we'll use the calculator to check ourselves is what I really want us doing. So as we look at A, g of x equals natural log of x plus 2. Okay, guys. Go back to your Algebra 2 brains, or where did we do this? Back in Chapter 2, I think?
Yeah.
What does that plus 2 do?
Left 2.
A plus or minus 2 in the parentheses with the x is left or right opposite side. So this is going to be a translate left 2. So I am going to write that down here. So we're going to translate left 2 units. Now, okay, before we take this to the calculator, think with me. The basic graph does what? I told you the basic graph cuts through 1 at the x-axis, right? So this is just a sketch of the basic graph. And it does something like that. Now, so that's just natural log of x. What's going to happen when we move that left 2?
It just goes over to negative 1, 0.
Okay, so it's going to cross through the point. It's going to cross through the point at negative 1. What's going to be the new asymptote? The y-axis was the asymptote. When we scoot 2 left,
Negative 2.
yeah, the asymptote that you're not going to cross is going to be at x equals -2. And so can you picture what this graph is doing now? It's going to run alongside this asymptote. It's going to cross through here and go over. Okay? If I look at the calculator, because it did talk about then using the calculator, didn't it? Let's see. Natural log of x plus 2. Okay? The red is the original. The blue is it moved left 2. Okay? Now, I forget. Sketch the graph using your calculator, labeling the asymptote and x or y intercept. We labeled the asymptote, or I did, x equals -2. My x-intercept is -1. And that's what we're looking for, is just the x-intercept there. And this red graph, if you want something so you don't confuse it, this red graph was just y equals natural log of x. Okay? Just for reference. Comparison.
So you don't have to find the y-intercept to do that?
No, you do not. It says x or y intercept. I don't know. We're going to focus on the main, the y-intercept is, you'd have to find that using the calculator. That's not something that we know. So, okay. B. H of x equals natural log of 3 minus x. There's two different ways we can look at this.
Well, if you flip it, it becomes -x plus 3.
Okay, hear me out. So that would be a reflection, and then it goes to the left 3.
Okay. So I think it is good to look at it like Logan suggested as -x plus 3, yes. Now, if you look at those two individuals, okay, what did you guys say? I don't even remember who said what here, but
He said, whatever we should flip it.
Reflection and left 3.
okay, it's the plus 3 in the parentheses is a left 3. This negative, it's a reflection where?
Across the y-axis.
Across the y-axis. Now, I'm going to call this,
I don't remember how to determine that.
okay, I'm going to call this option 1. And
inside versus outside the parentheses.
Hold on a second. I'm going to call this option 1 because then there's going to be a second way that I could do this and still get the same graph. Okay? And I'm going to write it down here as option 1 that we talked about. This is going to be a translate left 3 and reflect across the y-axis. Okay, so this is option 1. Now, here's my shortcut. Logan was questioning how, which reflection is which. I look at it as when the negative sign is on the x, it's a reflection across the other axis, the y-axis. So the negative on the x is the other axis, the y-axis. If you have a negative just out front of the equation or out front of wherever we're talking about, then I think of that as that's kind of like a negative on the y because it's on the whole function, which is y. So the negative on the y, the negative out front, then reflects across the x. Okay? Now, if we look at this, what do we say? We're going to translate left 3. So what's that mean?
Go -3. Well, are we drawing the original first?
I wasn't going to draw the original this time.
Your asymptote would be -3, and your intercept would be -2.
That's the left 3. What's reflecting across the y-axis do?
Makes it go positive.
To the right, yeah, left to right on this one.
Oh, crud. I totally botched this. because I started drawing it out here. So there's my 3 left. What happens when we reflect that across the y-axis?
Becomes positive 3.
I forgot where I was going with. I guess I didn't botch. I just forgot where I was going. That you're actually going to end up with the asymptote over here when we reflect it, and your intercept there.
Well, yeah.
Okay. My brain was going backwards. So what was going to be here is now going to do what?
Go opposite.
It's going to go, I made that a little steep. It's going to go that way. Okay. In my brain, I botched it because I shouldn't have put that other asymptote and intercept on there. Okay. Now, I want to talk about one other option here of how to rewrite. Because the other way to rewrite this, and it still works, is to go one step farther than what we did last time and take this negative and factor it out. Okay? And so if you take that negative and factor it out, it's natural log. And I'm going to have a negative, and then in parentheses, when I factor out that negative, it's going to have x minus 3. And we can also look at it like this. Okay? What changes here? It's the order of what you do things. Okay, you have a different direction, but also an order. So I'm calling this option 2. And the difference here is that if you work within those parentheses, that's a right 3. Okay, so the difference here is you are reflecting across, now we're reflecting across still the y-axis, but because we pulled it out front, it's a right 3. And so if you reflect across the y and then move right 3, it's the same thing.
I don't like that.
And that's fine, you don't have to like it. I'm not sure I like this one either, but I felt like I needed to mention it. So reflect across the y-axis, and
Because that makes me think, so if the negative was in front of the natural log, that's when it'd be a reflection across the x-axis. So a reflection across the x-axis would like make it, what would that look like?
They'd go upside down. Well, hold on, let me finish with this problem. If we reflect this across the y-axis, so keeping in mind your original problem, I'm not going to leave this on here, was this, right? Reflecting across the y-axis is going to make it like that. Moving it right 3 then takes that and puts it over here. Okay? So these are the difficult ones when you've got that negative in there. I get it. You have to be careful. Okay, let's look at C. G of x equals 3 log x.
It's a vertical stretch.
Okay, we have a number multiplied out front. It's a vertical stretch or compression or shrink, whichever word you want to use. Because 3 is a number bigger than 1, it is a stretch. So this is a vertical stretch by factor of 3. What's that going to do?
So think about 1, 0 being here. It would turn.
What are we stretching when we do a vertical stretch by a factor of 3? You're stretching the y values, right? So on 1, 0, your y value is 0, and 3 times 0 is 0. So 1, 0 stays where it is. Okay? It's the other values that will go up faster. So think about this. If you think about, here's my comparison. If you think about that as the original, when you put a stretch on it, basically, it's going to go up steeper. Okay? And the calculator does your best, best description there. So if we have log of x versus 3 log of x, blue is the original graph, red is the vertical stretch. It just goes up quicker. Okay? That's the big difference. And one more. D. What do you see going on with D?
It's just and go up one.
Yeah. Does it help you if I reverse it and say log of x plus 1? Does that visual help? And maybe you're thinking, yeah, I didn't need that, but if it helps, that, the plus 1 can go in front or behind. It doesn't matter. But it's not in parentheses with the x, so it is a translate up 1. Okay, what's that going to do?
It's just going to put your point at 1, 1 instead of 0, 1.
Normally we go through 1, 0. Now we're going through 1, 1. Something like that. Okay. So basically, it raises it up higher. Again, I don't want, I want you thinking about these without the calculator, but it is helpful to then kind of check and see what the calculator shows. So the red is the original, the blue is the up 1. Okay? And I guess I was thinking we had one on here, which is why I said wait earlier, but if it were to reflect across the x-axis, realize instead of going up, it would be something like that if it were to reflect across the x-axis.
The point would become like.
This point would stay the same.
Oh.
Because it would be, you would take that and flip it upside down. That would be your reflect across the x-axis. Okay? Okay, guys. You have the torturous 1 through 40. Some of you have already started, I've heard. Is it going quickly?
Yeah.
No, tell them no.
Okay, it's going quickly. And you have like 25 minutes of work time.